Hello, my name is Christopher Figuera, and I chose to do number 8 for problem set 2. So, question 8 states that you are considering three persons, A, B, and C, who are to be seated in a row of three chairs. Suppose A and B are identical twins. How many seating arrangements of these people can there be if A, if you are a total stranger, and B, if you are A and B's mother? All right, so this question seems a little bit confusing at first for A and B because in my mind, I thought, well, what's the difference between if you're a total stranger and A and B's mother? The twins are still identical, so uh, there shouldn't be a difference in the seating arrangement. But I thought about it some more and thought about it in terms of logic that for A, if you're a total stranger and you see total identical twins, you're not going to know the difference between them. So I said that since A and B are identical twins, A is equal to B. So I can just say there's basically 2A or 2B in this arrangement, or two elements of A, two elements of B, if you want to do it in that type of notation. So I made a chart for the seating arrangement. Since we do have one row of three chairs, we need to find how many different arrangements we can make. So for the first row, I did twin 1 or A, uh, complete stranger, and then twin 2, which is A in this scenario, since we're saying that both twins are identical and we don't know the difference between the twins. For the second row, or for the second scenario, I said A, A, and C. And then for the third scenario, I had C, A, and A. Now, if you try to rearrange this in any other way besides these three, you're basically going to have the same outcomes as one of the previous three rows. Because if we're treating A and B as identical twins, then we're saying that the elements are similar in a set. So you have three rows there, so there's only three total different arrangements you can have for set A. For B, again, I use logic for this one. I'm saying that since I'm thinking that A has to be different than B in terms of the answers, um, mother has to know the difference between A and B because she's a mother. She would be a pretty terrible mother. She didn't know the difference between her twins. So for this one, I treated A and B as separate elements. Again, I went through the process of creating every single different arrangement possible. So I started with, for rows 1 and 2, with A being the first chair. So for row 1, A is first, B is second, and C is third. Row 2 being A is first, C is second, and B is third. So that ends all the scenarios where A is in the front, or is in the first chair. Moving on to row 3 and 4, we have scenarios where B is the first chair. So for 3, I have B, A, C. For 4, I have B, C, A. Again, that cuts off all possibilities of B being in the first chair repeating again. For 5 and 6, you have C in the first chair. 5 is going to be C, A, B. And then 6 is going to be C, B, A. And then that's it. There are no other possible combinations or seating arrangements with these three. Now, if you want to think about it of the notations we've been learning and the material you've been learning and how to apply that, you can say this is 3 factorial. Um, 3 factorial is equal to 3 times 2 times 1, which is 6. We have 6 different arrangements on the left. You can also use what we learned in the second section, one of the final examples. It's like the P parentheses NK, where basically you have an n number of elements and then a k number of, the word is escaping me right now, but basically you only have k number of slots in some type of like pattern. So since we have three elements and then we have three available slots, chairs, it equals to 3 factorial over parentheses 3 minus 3 factorial. I should have put it here but this notation is basically p n comma k, which is equal to n factorial over parentheses n minus k factorial. Um, so we do the math. We still have 3 factorial on the top when we move to the right. 3 minus 3 is 0. 0 factorial is 1. So all we are left with is 3 factorial over 1, which is equal to 6. Thank you for watching.